Section 2.2 is all about the different slopes of lines. So we can have 4 different types of slope, right? We can have positive slope. That's going to be when your graph looks like it's going uphill. We can have negative slope. That's when your graph looks like it's going downhill. We can have no slope, right? Remember, this is when y equals some constant. Or we can have undefined slope, which is when x equals some constant. Vertical lines have undefined slope. What else is undefined in mathematics? Think about what have I told you you can never do. You can never divide by 0, right? It breaks all mathematics, means I don't have a job, right? So I bet you, thinking ahead, we can be like, I wonder if the fact that vertical lines have undefined slope has something to do with the fact that we might have to divide by 0. Keep that in mind as we move through this section. So the way we calculate slope is we define slope as the vertical change over our horizontal change. We can also call that the rise over run. So given any 2 points on our line, we take the difference in y values over the difference in x values. And it doesn't matter which point you let be your first point or which point be your second point, you're going to get the same answer. Also, we denote slope with the lowercase letter m, okay? And that's going to prove really crucial as we move through this chapter. So let's calculate the slope of these 2 lines. So let's do number 1 up top. So number 1, I have slope equals my change in y over my change in x. Let's let this be x1, y1, and this point be x2, y2. I'm going to go ahead and take 3 minus a negative 1 over negative 4 minus 2. That means I get 3 over negative 6, so my slope is, 3 over 4. 4 over negative 6, so my slope would be negative 2/3. And I want you to start to visualize when I tell you a slope is negative, positive, undefined, or 0, what this looks like. So remember, with negative slope, our graph's going to look like it's going kind of downhill. Next, for number 2, I have x1, y1, and x2, y2. I say my slope is going to be 2 minus 4 over 5 minus 1. That's going to give me negative 2 over 4, so I have negative 1/2. Again, the graph of this is going downhill. Now, I had said you should keep in mind the slope of the undefined slope of vertical lines because it probably has something to do with dividing by 0. Let's work through a bonus example that shows that. So if I have the point when x is 4, y is negative 3, and when x is 4, y is 7, if I want to go ahead and calculate the slope, remember I take my change in y over my change in x. The problem is if I have the graph of a vertical line, my x isn't changing, right? My x is constant. So keep that in mind. So as I solve this equation, I've got 7 minus negative 3 over 4 minus 4. That gives me 10 divided by 0, which is undefined. So because when we're working with vertical lines, their x-coordinate is constant, we're always going to get a denominator of 0, so our slope is therefore undefined. Now, earlier I had introduced the standard form of an equation. Slope-intercept form of an equation, if I solve for y, I'm going to get y equals my slope times x plus b. So b is our y-intercept and m is our slope, right? If I solve for y from standard form, this is going to tell me something about what my equation looks like. If I have its slope, I know whether it's going uphill or downhill. If I have its y-intercept, I have a place to start. So why don't we go ahead and this is a friendly reminder about if I have x equals a constant or y equals a constant, whether or not they have undefined or 0 slope. I bring this up really often because it's one of the most commonly missed questions on exams. You have been warned. So why don't we go ahead and graph these using our slope and y-intercept. So I have y equals 4x minus 3 and y equals negative 2/3 x plus 4. Let's go ahead and draw the nicest coordinate plane possible. I probably should have inserted one into the slide, but hindsight is 20/20. Okay, so remembering that slope is rise over run, I might want to write 4 as a fraction. I could write any whole number as a fraction over 1. So I have my y-intercept is negative 3. So let's go to negative 3. That's a point on the line. This is our y-intercept. We've got our y-axis and our x-axis. My slope is 4. That's rise over run. So if I'm going to go up 4 and over 1. That's another point on my line. Again, I can go up 4 and over 1. So there's our line, y equals 4x minus 3. And friendly reminder that every single point on this line will satisfy the equation. Let's change colors and graph y equals negative 2/3 x plus 4. So I know my y-intercept is 4. 1, 2, 3, 4. So this point right here is when x is 0, y is 4. That's our y-intercept. And my slope is negative 3. So my graph's going to be going downhill. Okay? So now I have rise over run, but my rise is negative. So I'm going to go down 2 over 3, down 2 over 3. Oh, that's 6. We found our x-intercept. And remember, you only have to find 2 points in order to graph a line. Oh, I was really off. But I just wanted to make sure we had some practice graphing using slope to determine where the next point on our graph would be. So why don't we go ahead and graph the line with slope 2/3 and a y-intercept of when x is 0, y is 4. So let's try and be a little bit neater. 1, 2. I'm trying to make this very uniform. Okay, not bad. I get myself like a B+ on this coordinate plane. So I already know my y-intercept. Let's graph this bad boy in blue. I have when x is 0, y is negative 4. So that's going to be right here. Then I have a slope of 2/3. So that's going to be rise over run. So I'm going to go up 2 over 3. Up 2 over 3. So here we have our beautiful line with a slope of 2/3 and a y-intercept of negative 4. And I can write this in slope-intercept form, right? If I've got y equals 2/3 x, slope x, plus your y-intercept, which in this case is negative 4. Next, why don't we go ahead and graph the line through the point when x is 3, y is 1, with a slope of negative 4. So I'm going to write negative 4 as a fraction over 1. So I've got a negative rise over my run. So when x is 3, y is 1, here we go. My slope's negative 4, so I'm going to go down 4 over 1, down 4 over 1. So here I have my line. And it would take a little bit of calculation for me to find the slope form, y equals mx plus b, which is slope-intercept form of that line. Parallel lines are lines that have the same slope. When two lines are parallel, they'll never intersect. So they could have the same positive slope. They could have the same negative slope. I'm trying to draw these as parallel as possible. They could have 0 slope, or they could have undefined slope, right? And in order to determine whether lines are parallel, we need to see if they have the same slope. So here I have negative 1/2, that's our slope. But this equation on the left is in standard form. So in order to figure out its slope, the best thing for me to do would be to solve for y. So I'm going to subtract 2x from both sides. That gives me negative 4y equals negative 2x plus 3. I divide both sides by negative 4. I get y equals 1/2 minus, x minus 3/4. So these two lines are not parallel because one has a slope of positive 1/2 and the other one has a slope of negative 1/2. So these are not parallel. You'd think I'd be able to spell the word with it written right there. LOL. Perpendicular lines are a little bit more complicated to determine if they're perpendicular. So perpendicular lines intersect at 90-degree angles. And in order to tell if two lines are perpendicular, the first one is that the product of their slopes is -1. Okay, so the lines are negative reciprocals. For example, 2/3 times -3/2. That would give us -6/6, which is -1. So if I had a slope of 2/3 and a slope of -2/3, oh, is that seriously the example below? Darn it. Then they would be perpendicular. Another thing to know is if a line is horizontal, so it has a slope of 0, and a line is vertical, so it has an undefined slope, those are always going to be perpendicular. So let's determine if the following lines are perpendicular. I have a slope of 3/2. I'm going to solve 2x plus 3y equals 6 for y. I have 3y equals -2x plus 6. Divide both sides by 3. I have y equals -2/3 x plus 2. And what I'm going to do now is multiply these two slopes together. So if I have 3/2 times -2/3, that gives me -6/6. See how creative I am? Which gives us a slope of negative line. So yes, these lines are perpendicular.